thinking that anything beyond our pond, anything beyond our little puny universe is science fiction. I was in the third dimension. I was in hyperspace. They were totally unaware that there was a universe beyond their pond.
Michio Kaku just confirmed something that could change how we see the universe forever. A strange object from another star system shot through our solar system, accelerated without fuel, showed no heat, and moved with terrifying precision. New data from 2025 finally explains what it was doing, and the truth is not just bizarre, it's deeply unsettling. This wasn't a comet, it wasn't an asteroid. According to Kaku and top physicists, this might have been an alien surveillance device, and it might not be the only one. The object that shouldn't exist. Back in 2017, astronomers spotted something strange. It came without warning, zipping through our solar system on a hyperbolic path, meaning it wasn't just orbiting the sun like the planets or comets usually do. This thing came from somewhere else entirely and was headed back out just as fast. They named it Oumuamua, which means a messenger from afar arriving first in Hawaiian. At first glance, it looked like a narrow, cigar-shaped rock, but the closer scientists looked, the less sense it made. Unlike every other comet or asteroid we've ever seen, Oumuamua had no tail, no ice, and no visible debris coming off of it, even when it got close to the sun, where heat normally causes frozen gases to burst out and create that familiar glowing tail. Nothing happened. It just glided through space in total silence. Then, as if that wasn't strange enough, it suddenly started to accelerate, not in some chaotic, drifting way. The change in speed was smooth, controlled, and completely unexplained. There were no jets, no visible fuel, just a mysterious push in the direction it was already heading. Astronomers tried to make sense of it. Maybe it was a comet after all, they said. Maybe it was shedding invisible gas we couldn't detect. But every telescope aimed at it showed the same thing. There was no gas. Nothing was coming off of it. It wasn't burning. It wasn't glowing. It was just speeding up. That's when people like Michio Kaku began asking the questions that others were afraid to. If this wasn't a natural object, what was it? And if it was using some kind of propulsion, where was it getting the energy? In 2025, Kaku and his research team used a completely new analysis method called quantum-enhanced optical modeling to re-examine the data. What they found shocked even seasoned physicists. The acceleration of Oumuamua was not only real, it followed a precise, predictable pattern every 7.3 hours.
But to me, the most significant is for what Oumuamua can tell us about the past of our solar system.
The time it took the object to complete one full rotation, its path subtly adjusted to stay perfectly on course. These weren't random changes. They were coordinated with its tumbling spin, matching theoretical models for a type of propulsion humanity has only imagined in theory, advanced light sail technology. The surface of Oumuamua appeared to reflect radiation from the sun in exactly the right way to propel itself. But unlike a simple sail, this one seemed to adapt dynamically. As it rotated, microscopic variations in the acceleration aligned perfectly with its changing orientation. In simpler terms, this thing seemed to adjust itself as it spun, keeping itself on a perfect trajectory without engines, without thrust, and without any emissions at all. According to Kaku, this would require something called responsive surface geometry, a surface that can adjust its reflective properties in real time. Humans have only begun theorizing about this kind of material. We can simulate it in papers and design it in labs, but we've never seen it function on this scale or in deep space. And yet, here was Oumuamua, tumbling through our solar system, using sunlight alone to glide along a path too perfect to be natural. Now, the conversation was no longer about what Oumuamua was. It was about who made it. If this was a form of passive propulsion, a light sail drifting through the stars, then someone had to build it. And if someone built it, they likely sent it here for a reason. And the deeper scientists dug, the more that reason began to come into focus. Because the next mystery wasn't how it moved, it was where it came from. And what they found left even the most skeptical astronomers completely stunned. the place it never should have come from. Once scientists confirmed that Oumuamua was accelerating in a way that defied natural explanation, the next logical question was, where did it come from? You would think tracing an object's path through space would be easy, but in reality, it's like trying to figure out where a leaf came from after it blows past you on the wind. Except in this case, the wind is made up of billions of stars, and the gravitational pull of every single one of them. Thankfully, by 2025, astronomers had something they didn't have back in 2017, the data from the European Space Agency's Gaia spacecraft. Gaia had mapped over 1 billion stars in 3 dimensions with mind-blowing precision. This wasn't just a sky map. It was a full simulation of how stars move, where they are now, and where they were millions of years ago. Using this database, scientists were finally able to backtrack Oumuamua's path through space, and what they found didn't make any sense at all. The object came from what is known as the local standard of rest. That sounds like a peaceful name, but it refers to the average motion of stars in our galactic neighborhood. Most things in our part of the galaxy move relative to this standard. Oumuamua matched this motion so perfectly that at first, scientists thought it must have been floating lazily along with the stars. But here's the twist. It didn't come from a place where anything should be moving at all. Its exact trajectory traces back to a region of space with almost no gravitational activity. There are no binary star systems nearby, no large stars, no supernovae, and no clusters of stars dense enough to eject an object like this. In astrophysics, objects are thrown out of their systems through dramatic events. A pair of stars slingshots a planet during a close pass. A star explodes and ejects debris at high speed. But in the place where Oumuamua came from, none of these things are happening. It is a quiet zone, a place where everything is so gravitationally stable that nothing should ever be kicked out into space. And yet, that is exactly where this object came from. To make things even stranger, the exact origin point lies in a part of space that is not just quiet, but unusually empty.
Constants of physics and more in cosmology, and they look like they all have nothing to do with one another.
Astronomers call it a gravitational dead zone. It is not entirely devoid of stars, but those stars are isolated and slow-moving. There is no visible reason why anything in that region would have gained enough energy to travel all the way to our solar system, not without help. This is what got Michio Kaku's attention. If you wanted to design an object and send it across the galaxy without anyone being able to trace it back to its launch point, that would be the ideal location. A place where no one would expect a natural ejection. A place where an object could drift unnoticed for thousands or even millions of years before quietly entering another star system. A place that would leave no fingerprints. Kaku's team ran the numbers again and again. The data kept pointing to the same outcome. Oumuamua came from a place where nothing should have pushed it out, and it arrived in our solar system with a trajectory so clean that it looked like it had been planned. This wasn't a rock that got flung into space by chance. This was something that appeared to have been launched. That is when the idea started to shift from theory to possibility. What if this object wasn't a random visitor, but part of something larger? What if it was a probe? Not the science fiction kind with blinking lights and antennas, but something far more advanced. Something so subtle it could slip through unnoticed. Something that had no need to make noise or leave a trace. Something designed to enter, observe, and exit without detection. And then came the question no one really wanted to ask out loud. If this thing was sent deliberately, and if it came from a place where it should not have been moving at all, then who put it there? And why choose our solar system as the destination? Because, as scientists would soon discover, the object's strange behavior did not stop at its origin point or its propulsion method. The rotation pattern of Oumuamua was about to reveal something even more disturbing, something that looked a lot less like nature and a lot more like programming. The rotation that suggests programming. For months after Oumuamua passed through our solar system, astronomers were locked in debate over one peculiar trait that just refused to make sense: its rotation. When it was first detected, scientists noticed that its brightness changed drastically every few hours. That brightness variation led them to believe the object was spinning, and based on those light curves, it became clear that the rotation period was about 7.3 hours. At first, this was chalked up to natural tumbling, something you might expect from an irregularly shaped rock tossed through space. But in 2025, new analysis revealed something that left researchers speechless. Michio Kaku and a team of astrophysicists used deep learning algorithms to review the full dataset from Oumuamua's brief visit. These neural networks were trained not to find simple patterns, but to detect mathematical consistencies so subtle that human researchers might overlook them entirely. What the AI found was not chaotic tumbling, it was deliberate, precise rotation. The object wasn't flailing around like space debris. It was moving with purpose. The primary rotation held steady at exactly 7.2 hours, with a margin of error less than 0.002%. That level of precision alone raised eyebrows. But there was more. Superimposed on that main rotation cycle were smaller, repeating movements, micro-rotational adjustments that occurred every 43.8 minutes. These movements weren't just random shifts. They were consistent, patterned, and regular. And here's where things started to sound less like astrophysics and more like engineering. As the object spun, it gradually exposed different sides to the sun. These adjustments allowed it to modulate how it interacted with solar radiation. In spacecraft design, this kind of controlled spin is used to regulate temperature, distribute energy across surface panels, and maximize solar energy collection. It is called scanning rotation, and it serves multiple roles: preventing overheating, balancing structural strain, and maintaining direction. Now apply that logic to Oumuamua. If it were a passive probe drifting through space, this kind of rotation would be perfect for collecting energy and data. The spin would allow different surfaces to absorb solar radiation, cool down in sequence, and possibly even scan its surroundings like a rotating surveillance dish. The consistency in timing was not just efficient, it was elegant. And the elegance didn't stop there. This rotation pattern, when mapped over the time it spent within our solar system, revealed something even more deliberate. At no point did the object tumble in a way that would lose orientation with respect to the sun. Instead, it kept itself optimally aligned throughout its closest approach, as if maintaining a line of sight with both the sun and Earth. It behaved like something aware of its position, like something built to navigate, to adjust, and to record. Kaku's team also cross-referenced the rotation pattern with known spacecraft behavior. The results were chilling. Oumuamua's motion mimicked the scanning techniques used in space probes designed to survey terrain or monitor radio signals. On Earth, satellites spin to evenly distribute exposure and scan the planet in wide sweeps. Oumuamua's motion did the same thing, but at an interstellar scale.
And Oumuamua was moving away and fading very rapidly.
And then came the most provocative conclusion of all. This rotation pattern was not obvious in the original data. It only became visible through enhanced AI processing, implying that the object might have been deliberately designed to appear random on first observation. In other words, its true behavior was cloaked beneath what looked like noise. And only after applying advanced algorithms did the order beneath the chaos become clear. This, more than anything, is what led Michio Kaku to change his stance. He no longer referred to Oumuamua as an anomaly or even a natural oddity. He began calling it what he now believes it to be, a technological relic, possibly damaged, possibly dormant, but almost certainly manufactured. And if that is true, then the spin, the silence, and the precision are not accidents. They are features of a machine built to observe, to drift unnoticed, and to scan whatever it passes. What's more, if this was a relic, something broken or left behind, then the natural question follows: what would a fully operational version look like? And has one already passed through without being noticed? Because the most unsettling part of all wasn't the spin, it was the silence. No signals, no transmissions, no beacons, just the whisper of something ancient moving past Earth like it was watching us from the corner of its eye. And if that object was silently scanning Earth, was it alone? Because in the final chapter, we'll look at the coldest, most unnerving part of this story, the thermal signature that never existed, and the possibility that Oumuamua was not just quiet but actively hiding. The thermal ghost that slipped past us. If an object comes this close to the sun, it should get hot. That is one of the simplest truths in physics. Everything we know about matter tells us that when something absorbs solar radiation, it must re-emit it as infrared energy. This is why even the darkest, coldest comets still glow in thermal scans. But when the Spitzer Space Telescope turned its highly sensitive infrared detectors toward Oumuamua in 2017, it detected nothing. No glow, no heat, no signature of any kind. It was as if the object absorbed sunlight and kept it locked inside without letting any of it out. At first, scientists thought it must have been a mistake. Maybe Spitzer missed the object. Maybe the calculations were wrong. But in 2025, new enhanced thermal mapping algorithms were used to reprocess the data. These tools, more powerful than anything used before, confirmed something that should be impossible. Oumuamua had passed within 0.25 astronomical units of the Sun, closer than Mercury, where its surface temperature should have reached over 500 degrees Fahrenheit, and yet it showed no thermal emission, not a trace. This finding created what physicists are now calling the thermal signature paradox. There are only a few ways this could happen, and none of them are comforting. The first possibility is that Oumuamua is made of a material unlike anything naturally occurring in space, something with extraordinary thermal insulation properties. Materials like this do not exist in any known asteroid, comet, or interstellar object. Even the darkest natural substances will still radiate heat. The second possibility is even stranger. The object may be covered in metamaterials, engineered surfaces capable of bending or blocking electromagnetic radiation. These are not science fiction. NASA has been experimenting with similar coatings for stealth satellites and thermal regulation, but the key word is experimenting. Nothing close to what was seen in Oumuamua has ever been built by humans. Then there is the third and most disturbing option. The object was deliberately cloaked, not visually, not with camouflage, but thermally. In other words, it was designed to avoid detection by infrared telescopes. This is what truly caught Michio Kaku's attention, because if you wanted to send a probe to study another star system without being noticed, this is exactly the kind of technology you would need. No fuel trails, no light emissions, no heat, just a silent, invisible machine slipping through space, unnoticed until it is already leaving. By 2025, physicists had reached a sobering conclusion. Whatever Oumuamua was, it was not just drifting, it was hiding. And the only reason we even saw it at all was because it happened to pass unusually close to Earth. If its trajectory had been just a few degrees off, it might have entered and exited the solar system without anyone ever knowing it was there. And if that happened once, how many other times has it happened without us noticing? This led scientists to revisit the idea that Oumuamua was not just an object, but a message. Not one we could read or hear, but one encoded in design. It may have been a passive observer, gathering data, scanning radio signals, analyzing atmospheric composition, and quietly transmitting everything it learned back to its origin. In fact, data from 2025 shows that during its closest pass to Earth, the object would have been in a perfect position to absorb global electromagnetic emissions for over 72 hours, long enough to capture an enormous amount of information about human civilization.
Science fiction. There's no world of up. Up does not exist.
And if it was scanning, then it was listening. It heard us. What Michio Kaku now fears most is not that Oumuamua was alone. It was only the first. Using new models based on detection probabilities and current observational limits, astronomers now estimate that objects like this might pass through the inner solar system as often as once per year, but most go unseen. Their size, speed, and lack of emissions make them incredibly difficult to detect. Our telescopes, even our best ones, only catch a fraction of what flies by. That means we are not looking at a once-in-a-lifetime anomaly. We are looking at the beginning of a pattern, A system, a quiet survey of our part of the galaxy by machines we did not know existed and still do not understand. The real message of Oumuamua might not be what it was made of, or where it came from, or how it moved. The message might be its silence.
This pond of hyperspace, then all the laws of physics just fit together like a jigsaw puzzle.
Its presence, its timing, because if it scanned us, and if it sent that data home, then someone, somewhere, already knows we are here. And if we only saw this one because it passed close by, it stands to reason there may be others, already here, already watching. And if the next one does not fly past, but slows down instead, what happens then? We only noticed Oumuamua by accident. Everything about it, the silence, the motion, the vanishing heat, suggests it was built to avoid being found, and that should make us ask what else we've missed. If this was a messenger, who sent it? And what are they waiting for? Drop your thoughts in the comments, subscribe for more stories the mainstream won't touch, and stay alert. The next object may already be on its way. We just haven't seen it yet.